Welcome back. Now we're going to learn about some regulatory functions of the kidney. So when we are looking at this, the first thing we're going to look at is water salt balance. Then this is what is going to enable us to maintain our blood volume and thereby our blood pressure. This all works together. And then we're going to look at our acid-base balance. And we've looked at acid-base balance quite a few times. So this is like pulling our equation into play once again. So let's get started with our water salt balance. And we are going to start with a decrease in blood pressure. So maybe you have a blood loss, or maybe you're just have a decrease in blood volume because you're dehydrated. This is going to be detected by that juxtaglomerular apparatus, those specialized cells in the afferent arteriole. Those are baroreceptor cells in there, and they're going to, those cells that are talking to those specialized cells in the distal convoluted tubule. Okay, so that juxtaglomerular apparatus, they detect, oh my goodness, there's a problem with the blood pressure. And so what's the kidney going to do? It is going to kick out that hormone renin. Okay, so now what renin does, the details, these first couple of steps of what renin does, you don't have to know for this course, but there are other organs involved. So what you do have to know for this course is that the kidneys, as a result of this, are going to kick out renin. But let me show you what renin does, because it's kind of amazing. There is a compound kicked out by your liver that renin converts into something else, and then that something else travels to your lungs where it picks up an enzyme which converts it to something else, and it's that other thing that then goes to your adrenal gland, to the cortex, and that's what has the adrenal cortex kick out aldosterone. And it also will go to the neural hypophysis to increase our antidiuretic hormone release. So what do you need to know for this course? After you have renin, you need to know ... aldosterone will increase from the adrenal cortex, and antidiuretic hormone will increase from the posterior pituitary. But you also need to know what will happen as a result of both of those. From aldosterone, sodium and water will both be reabsorbed from the distal convoluted tubule as well as the collecting duct. And from antidiuretic hormone, water will be absorbed from the collecting duct. So the net thing is, as a result of decrease in pressure, that this juxtaglomerular apparatus from the afferent arteriole and the distal convoluted tubule, what is going to happen is 99% of the sodium that was in the filtrate ends up being reabsorbed, causing 90% of the water in the filtrate to be reabsorbed, sent back into the bloodstream. And this is going to happen through the involvement of 3 different hormones, specifically renin, causing aldosterone production, and antidiuretic hormone increases. All right. So hopefully you understand our miniature version. You do, for this course, you do not have to know this angiotensinogen, angiotensin 1, angiotensin 2 part of the pathway. So let's talk about a diuretic, because lots of people have heard about people taking diuretics, or water pills. So a diuretic is something that increases the amount of water in the urine. So have you ever taken anything that makes you need to pee more? Well, that's a diuretic. So, classic example, drinking caffeinated beverages like coffee, Coca-Cola, Diet Coke. So what happens is caffeine increases the blood flow to the kidneys. So more blood flow going into the kidneys means more filtrate. More filtrate means more urine output. But in addition to that, caffeine also decreases the amount of sodium reabsorption. So it's a two-pronged approach to increasing your diuresis. All right. Have you ever had an alcoholic beverage and noticed if you're sitting at a bar, you have to go to the bathroom more often? Well, sometimes that's a good thing because it makes you realize maybe you need to slow down your drinking. Well, here's how that works. Alcohol inhibits the anti-diuretic hormone. So you're inhibiting an inhibitor, thereby causing a diuresis. All right, so people who take water pills. So like some people take water pills because they have peripheral edema, swollen ankles, they have high blood pressure, they have heart failure. So there's different kinds of water pills, but they're all going to be working on the tubules to decrease the sodium reabsorption. Some work on the proximal convoluted tubule, some work on the distal convoluted tubule. The most potent ones are going to be working on the loop of Henle, where all that active transport of the sodium occurs. So if we can block that, then we're really blocking our sodium reabsorption going on. And lastly, because we can, let's talk about cigarette smoking and what happens there. Well, as you know, cigarette smoking decreases the renal blood flow. A decrease in renal blood flow means a decrease in filtration, which means a decrease in urine output, which is not a good thing, which means if you've ever been at a place where there are smokers and drinking, and if you are a non-smoker drinking with a smoker who is drinking, what you will notice is that you end up having to go to the bathroom a lot more than the smoker has to go to the bathroom, because the smoking negates the inhibition of the ADH. So the smoker just has a normal urine output. All right, let's talk about the acid-base balance. So if you recall, the normal pH scale is from 0 to 14, and everybody thought our bodies were perfectly neutral at a pH of 7. And I said, nope, your body does not like to be a pH of 7, and most of you with a pH of 7 would be dead. In fact, if we look at the pH range that is compatible of life, it goes from a low of 6.8 to a high of 8. As I said, we like to be a little alkalotic. So please make sure you understand that the normal blood pH is 7.35 to 7.45. So the average is an alkalotic 7.4. It is not a pH of 7, where 90% of you will be dead. Not a good place to be. So how do we control that pH? Well, the number one way we maintain the pH is the carbonic acid system, which is the one equation that I've asked you to learn, where carbon dioxide is going to bind with all that water that we have in our blood. So add those two things together, that gives us carbonic acid. And then that can break down and give us a hydrogen ion, and what is left is a bicarb ion. So let's look at the left side of the equation first, carbon dioxide. Well, we can change how much carbon dioxide we have by changing two things. We can change how fast or how slow we are breathing, so the rate of our breathing. And we also can change our depth of breathing. We can take deep breaths, or we can take very shallow, like And those two things will affect our blood carbon dioxide levels. For instance, if we increase the rate of our breathing, we can blow off extra CO2. And so if we want to re-inhale some of that carbon dioxide, we would breathe into a paper bag, which would mean we would re-inhale some of that carbon dioxide. But if we don't want to blow off as much CO2, we could just slow down our rate of breathing, and then our carbon dioxide levels would go up. And so by affecting the rate of breathing and the depth of breathing, we can change how much available hydrogen ions there are and therefore change our pH. So how does that work? If we decrease, for instance, our depth of breathing, making it shallower, and slow our rate of breathing from like a normal of 12 or 14 and drop it down to 4, then we're not going to blow off as much CO2. So our CO2 levels are going to go up. So we always have enough water, so all that extra CO2 is going to bind with the water. So we're going to make more carbonic acid. And that carbonic acid is going to dissociate, so we're going to make more hydrogen ions. And so the more hydrogen ion we have, what happens to our pH? Well, remember, the higher the hydrogen ion, the lower the pH. They are inverse of each other, okay? So they are directly proportional. If we raise our carbon dioxide levels in our blood, we're going to be raising our hydrogen ion levels and dropping our pH. If we blow off our carbon dioxide, that means we're going to be lowering our hydrogen ions and raising our pH. So this is the side of the equation that our lungs deal with, the carbon dioxide. But now let's look at the hydrogen ions and the bicarb ions. What can we do with these? Well, we can send these from the filtrate back into the blood. Or we can send these into the urine, into the toilet. So the kidneys deal with the right side of the equation. And by dealing with this, they can affect the pH. So if they send, and they're going to do both. They're not going to do one or the other. They're going to do both. So if they're going to send a hydrogen ion back into the blood, that's going to lower the pH. And that means that this, with the negative ion, they're going to send that into the urine, because if they sent that back into the blood, that would raise the pH back up, which would defeat the whole point of sending the hydrogen ion back into the blood. So if you want to raise the hydrogen ion content in the blood so you can lower the pH, you would have to send this bicarb ion into the toilet. If you wanted to send the hydrogen ion into the toilet, so that you would do the opposite with the pH, then you would send the bicarb back into the blood to raise the pH, and you would send the hydrogen ion into the toilet. All right, so as you can see, this scale is on a pendulum, and this is how we're going to control that pH between that 6.8 and that 7.8, but essentially, we're going to keep it between 7.35 and 7.45. With the respiratory control dealing with the carbon dioxide, which we can do really quickly just by changing our depth of breathing and our rate of breathing, and the renal control by our hydrogen ion and our bicarbonate ion, either reabsorbing them or excreting them. So, and don't forget, more hydrogen ion in the blood means a lower pH. So, Here's the question for you to work out. What would the kidneys do if they needed to raise the pH? So figure out, what do they need? Do they need more hydrogen ion or less hydrogen ion? Based on that, what are they going to do with that right side of the equation? Deal with both ions. Okay. And then go, well, what would the lungs do to raise pH? What would the lungs have to do? What would have to happen to carbon dioxide to have the effect over on the right side with the hydrogen ion for the kidneys to do that? Would you need more hydrogen ions or less hydrogen ions? So figure out what the lungs would have to do. So take some time on this slide, use the previous slide and figure this out. That's it for this section. Thank you so much for all your hard work, and I will see you on the final section for the urinary system, where we talk about renal failure.